So the query information here, a few of things I want to kind of highlight, emphasize a little bit is the session type. Here, there's Hive Server 2 and the BUX session. So the BUX session is the one that you executed through Impala shell. And the Hive Server 2 is if you execute it through other like Q or JDBC clients, those are all through the Hive Server 2. Hive Server 2 interface, not go through Hive Server. This Hive Server 2 is just a session type. Yeah. Kudu. Kudu is just a storage. So the session part, there's no difference matters like for any of the storage. No matter if you use HDFS, Kudu, S3, or HBase, the session part is the same. It's more related to which client you use, the session type. There's two session type. One is Hive Server 2, another one is BUX. So actually, we recommend to use Hive Server 2. I think the BUX one at the end will be replaced by just the Hive Server 2. Yeah. So the Impala version here is shown in basic query information because each version might have different feature. So sometimes you want to pay attention to the version here. This one, since I modified it a little bit, you don't see the real string here. Usually the Impala version here will indicate that if this version is a debug version or release version. Since Impala is written in C++, the performance between debug and release version can be quite different. So we noticed that for sometimes the customer probably for debug purpose, they switch to debug version, but they forget to switch it back and they complaining about the slow performance. So pay attention to which version you're using. It's always include both release and debug so that you can switch. Like even on the live cluster, you can switch. You just need to restart it. So sometimes for debug purpose, we do need to switch to debug version to get a little bit more debug information. It's a setting in CM. If you are interested, I can show you later, like in the break, and where in the CM. Yeah. One more thing I want to highlight is at the bottom part, you can see the query option here. So this one tells you that this query is run with which options, because the query option is a per session setting. So you might set some query option for this session, but not set it for others. So that can cause sometimes the performance difference, some different behavior. You could see that. So you better always examine the query option here to see that if your query running with the same option. So next thing is the query timeline. The query timeline is split to two parts, front end and back end. The planner timeline is the front end one, and the query timeline is the back end. So front end, it has a lot of detail, but usually you don't need to care about too much about the front end timeline. The only thing that can be significantly slow in the front end side is metadata loading. So in the newer version, now we list the metadata loading separately. You will be able to see some metrics in the planner timeline if the metadata loading takes time. What? I think 513. Yeah. This is 14, but it depends on if your query spend time on metadata loading or not. If the metadata already cached, we don't show it here.
Oh, so, okay. But otherwise, there would be a line, the first line before analysis finished to say metadata?
Yes, it will show metadata loading. Yeah. it will show that. Yeah, I know that's quite confusing for lots of times. That your query kind of miserable, slower, especially at when you just start your cluster, restart your cluster. Yeah. At the query timeline part, there's several different phases after the planning finish, and we will submit the query to admission control. So now all the recent release, the admission control is always enabled, so that you should always see the admission control time usage. And after that, the fragment will be distributed to all the backend. So there's also the backend time here, actually. So the backend time depends on how large your cluster. It might sometimes take a couple of seconds if it's a very large cluster or some of the nodes has network issue. Admission control, I'll see at the end if we have time. Yeah, I'll see if we have time, I can cover a little bit about admission control. It's just this is not part of the plan profile part. Yeah. So you can see that at this part, it indicates that all the fragments are distributed. So here is almost take 5 seconds. It doesn't mean that every fragment's distribution take this time, but the total, in total, probably because some hosts are slow, so that to finish distribution, the plan totally take 5 seconds. So one thing that always confusing is this first row fetched. So at the beginning, a lot of people think that the first row fetched means that the query execution is done. That's not the case. The first row fetched only means the first bench is ready. Since Impala is doing this pipeline execution, so it's trying to provide you result as fast as possible. So it scans some data. As long as it can continue for the next step, it will execute the next step. And until that it reach the coordinator layer, like have some result ready to show the client. So that means this first row fetched. If you're doing a select count query, you only have one row to show. Then the first row fetch is the same as your total query finish time. But if you are doing, for example, select with a lot of drawing aggregation and then limit maybe 10,000 row. So this first row bench just means the first 1,000 row ready. You still have like 9,000 row you need to processing to fetch. So just be clear, like this doesn't always mean, most of the time actually, doesn't mean that the query execution is completed. So the query completed and completely removed, release all the resource at the unregistered level when you unregister a query. Depending on which client you use. So some client, like especially the JDBC client or Hue, those kind of client, they fetch first bench and they might just waiting there and they don't do anything. So in those cases, the query are still like in the system, holding the resource, and they're not completed. So that's a lot of times when people use Hue that they find out that even though that seems no query running, but I couldn't execute new queries. That's because those Hue clients like holding those query take the spot and the new query cannot get in. So you have to examine your application or Hue, make sure that they behave well. Once they finish, they should close the query. That's where the query is really unregistered and it's removed from the system, release all the resource. In Hue, which means that you actually close the tab. You have to close the tab. Yeah. For others, like for example, if you use the BI queries, And those should be, there's something like a close call. So you can just call close, it will close the query. The best way is to close, but there's some configuration that can help at least automatically close it sooner, like the query timeout. There's some query idle timeout, session idle timeout. Those kind of configuration can help at least to close the query sooner instead of like them hanging there.
Although it doesn't really close it cleanly, that shows us errors.
Yes. Yeah. For Hue, yes, we do think. Mhm. So the impact is more on the memory usage side. It doesn't really use any CPU because you're not doing any execution, but because the Impala server still need to hold the intermediate result, everything, they use memory. Yeah.
If there's a low on memory, will that change the execution plan?
It doesn't change execution plan, but it impacts the resource usage, so it might block the new query being executed if you're using automation control. Or you might see more query filled with out of memory because you don't have enough memory for them. We'll keep improving the resource management, resource allocation part. So I remember in the recent release, we're trying to be more aggressively kind of like recycle the resource. So if we detect that this query is not doing any work and part of it should not be needed anymore, we just recycle that memory. Yeah.
Would the memory be taken into consideration for the join type?
Join execution will impact the memory usage. So for join order, when we decide the plan, we always the thing that we always looking for is cost. So the cost come from the memory usage, network usage. I'll provide the formula later. You can see how the Impala planner doing the adjust the join order based on those cost estimation. Yeah. What do you mean get new data? Yeah. Mm-hmm. Yeah. It's whenever you run a query, it's a completely new request. So right now there's no. I mean, even though it keeps the result set in memory for this query, it cannot use that one for another same query. Hue is just a client, but the result side is holding at the Impala server side. I mean, even though we have the result side right now, it's not that easy to do the common cache layer for multiple queries. So we cannot share the result set for different query right now. Okay. So one more part about the basic summary information in the query profile is the client fetching time and the raw materialized timer. So this part is not the server side, it's more the client side. So if your client side, like we already discussed a lot, if your client doesn't fetch, then the client waiting time can be very long. But actually, during the waiting time, the Impala server doesn't really do any work. So the raw materialized time is for the final result. The Impala server have to combine them, format them, and present it to client. So there's a different option. By default, it's always do the pretty format. So it kind of show you nice table, everything aligned in the column. So that actually take a lot of CPU to do. If you don't need that, you should just use the dash capital B option to not using the pretty format. That can reduce the row materialization time for the client for the final result. Yes, it could be. But the waiting time here depends on how long it is. You can see sometimes the query execution probably only take 2 minutes, but the waiting time is 2 hours. That you can compare that one also with the first row fetched, because before the first row fetched, that really means all the work server is busy doing all the things to provide you first row bench. After it provides the first row bench, the next part it could waiting for client. Oh, that's because GDBC, UDBC usually very slow to transfer large result set. So, so if you have the case that you have a large result set, the best way is to write it to the storage, like do a insert as select, dump all the results to HDFS to your local file that way, instead of like just sending it back to client. Client waiting? Client waiting a lot of times is just the client doesn't do anything. Like if you think about normally how the business user or the data scientists do their work, they execute the query and they see the first row bench display to them. They probably start looking at it, thinking about things, and then maybe switch to do something else, and they just not continue finish the query. Yeah. They don't close it. They don't keep fetching the next. That causing a lot of waiting time. What? No. This is fetch wait time, so it's already excluded the fetch time. Yeah, yeah. Correct. That's only for command line. The hue, but the hue actually is pretty smart. Is only display the first bench. Unless that you keep scroll it, it will fetch next, so that it doesn't fetch a huge result. But on the Impala shell side, by default, we give you all the results. Yeah, so that if you have a huge result, that can take a long time. Okay. Okay, so that's all the basic thing about the query summary part. The next thing, the most important thing I think like you should remember is how to read the execution summary. Let's see. So it depends on how complicated your plan is. The execution summary can be pretty long, but I want you just right now just remember the first line here. Just remember the first line. This is how it organized. So what's going on? No, I think the PowerPoint might crash. Okay. Good. Okay. So just remember the first line here. Yeah, the hiding part. Um, Okay, because I trying to zoom it, but somehow it doesn't work very well. um, because all the um after the header, all the rest part is a detail plan, and each one based on your query that can change. So when we work through the profile, you can see the details about that. But right now, you don't need to worry too much about the details here. Just remember this headline, this row here, like how they organized. Yeah, just per column how they organized. So the first column is mapping to the plan. It's mapping to the plan, how your plan tree is there, and you can see that each operator is listed, one line for each. That's the first column. And the second one is the host. How many hosts are involved in executing each operator? Next, the two column together is average time and max time. So average time is the average of all this fragment instance or all this operator. How much does it take? And the max is the slowest one. So this tells you that first, if there's any operator is bottleneck. So if you are looking compare the operator just to see that which one take longest time. So that's possible that one is your bottleneck. Then compare the average and max to see that if the max and average have a big difference. If there's a big difference, that indicate like your host, there's some skill there. So not every host spend the same time to do similar amount of work. Supposed to be similar amount of work for each host. Which one? US US is nanoseconds. Yeah, yeah, nanoseconds. Okay, microsecond. Oh yeah, right, microseconds. Yeah, yeah, MS milliseconds, and there could be seconds or minutes. There could be. Yeah, yeah. The NS is nanoseconds, and that US is microseconds. Sorry. You probably don't want to do that because you want to see the tree structure. If you just sort it by that order, you can't break the tree structure. You don't know that this nodes what's the one that upstream of this operator. Because a lot of times you can see the time here. This is the including probably the whole part of this fragment. It's not just the hash join itself. It including its child. Yeah. It's from bottom up. Yeah, usually it's sequence. Yes. It can be parallel depending on your branch. So the branch can be running in parallel. Yeah. This one only show you the max, but in later in the fragment detail, you can find out which one is the slowest one. Those are serial. Yeah, what I mean is the branch can be executed in parallel, but it's a left deep tree. So your left side is always executed in serial, but your right branch depends on what they are. They can be parallel. Yeah. So next one is the number of rows. This give you idea like the intermediate result of each operator, how much intermediate result they generate. And the right side is estimated one. That's what planners think that how much intermediate result this generated. So usually the best will be that the estimation match your reality. But it's very hard to make it very accurate, especially like when you do the planning based on the statistic. If your statistic is not up to date, or if your data is not distributed evenly, then the selectivity estimation can be bad. So sometimes the planner do generate wrong plan, but you can, based on the estimation and the reality, to see that if the plan is good or not, should you add hint to adjust the plan manually. So if you ingest the data daily, and what our recommendation is for there's two type of stats, table stats and column stats. Table stats is mainly the cardinality per partition for the whole table, like that. So the cardinality, it's better to keep it as accurate as possible. And for the column stats, that's NDV, number of distinct value per column. And usually this value doesn't change that much. So for this one, it's only if there's more than 30% of total data change, we recommend that you need update the column stats. So depend on the size of your table. If it's small enough, I recommend just do compute stats for the whole table to get both table stats and column stats updated. But if your table is very large, compute stats is too costly, take too long, and I would recommend that you do select count to get cardinality, set that manually, and then do the full recompute stats just after 30% of data change. I know that but the way that Impala's planner use, even there's a partition, the column stats, it doesn't do it per partition. The column stats is still per table. For the cardinality, that should be per partition. You can set that per partition. Yeah. Yeah, set stats. Yeah. Yeah. Next two column, that's the memory usage here. So again, there's the real memory usage and estimate memory usage. So you can, from here, you can see that what is your most expensive operator that use most memory. You can also see that the estimation, if it's accurate or if it's far off. So last one. Okay, I'm not able to see here. So the last column, that's just give you a little bit more details about which table this operator will be related to. Like for example, for scan, which table it scan, and if it's drawing, what kind of drawing predicates here, some basic information. So it just help you to quickly find out the details from the plan. Okay. This one, can you guys read it, or do you still need to zoom in? So as mentioned before, from the execution summary, that you can easily find what's the bottleneck. So which operator is the slowest one? For this one, it's probably not very big difference, but you can see that the ID2 hash join here is the one take longest time. By the way, for the operator, you can see there's a lot of numbers for each one. So that's the operator ID, kind of an identification for each operator. This, you can map that to the profile details. If you need to find a specific instance for operator, you can just search that by ID in the profile. So the second thing in the execution summary is you can find the skill here. So this one is more obvious. You can see from the hash join here, the slowest one compared with the average one is like 6 times, almost 6 times. And from that slowest one, you can track down to the downstream to see where it come from. So it's come from this scan. Then you can go to the scan nodes detail to see that what caused this skew. Is it because the data skew or what else? So now let's just walk through some queries. I think that will really help you guys understand the profile. So everyone probably either already downloaded the profile or have access through internet. Okay, cool. So I actually already gave hint by the file name because I want to organize it. So can take just a few minutes, look at the first two, the 001A, 001B, and to see the difference. Start from the query plan. Start from the execution summary to see that the execution time, where the difference, and then you can go back to the query plan. You can just access the GitHub link. You can access the GitHub link, and if you are at here, there's an easy way you can just clone or download. You mean this link? Okay. Can you read it? Okay. Just for reference, look at it. Unfortunately, I couldn't provide you a real class to run the query. Yeah. Yes, I'm gonna walk through. So I just want to give everyone a few minutes to have a chance to really look at it. Yeah. The query actually is showing here in the query summary page. You can see the query SQL statement. Yeah. Yeah, by the way, ask questions if you couldn't find any information, because basically the query structure here, as explained before, you will see the summary here first, the basic information, which user executes the query statement, any query options, and then the query plan here. Then the next is the summary. So don't bother about looking below the timeline part. You don't worry about this part. Just looking everything until probably here, the query timeline. Predicates push down. Predicates is kind of like a filter. So when you're writing the query, like for example this one, when you're writing the query, the condition here, we call it predicate. So that's a filter. And depends on where the filter is, we're trying to push that to the scan level. So remember, the plan is like a tree. So if you can push the predicates to the low level, as low as possible, that you can filter the result as early as possible and has less intermediate result generated. Right. That one, that's partition pruning. That one is partition pruning. It's slightly different than predicates pushdown. For predicates pushdown, that you still need to scan all the data. It's just that the output will be smaller. But if you don't have these predicates, you scan the whole data, you return the whole data to the upstream operator. Uh-huh. You do need to scan the whole table. No, because you're getting average. You still need to scan the whole column, but you can try to improve the performance by just select the needed column So if you're using parquet, then Impala will know that, oh, you're only doing the average for column A. So I'll only scan column A. I don't even need to touch, bother look at other columns. Yeah. Approximation for what? For average? Uh, not as I know, like for the min max, you cannot do that. But we do have other optimization, like to quickly give you the min max. For example, for the parquet, since parquet has its own metadata, file metadata, usually you can get some parquet data statistic into parquet's own metadata, like min max for the column or dictionary for some of the column, so that when we're doing the scan, we don't really actually need to read the whole column if we find out that this value already fall out of the min-max range. Yeah, that's different optimization. Yeah. Actually, quite a lot. It's all the numeric and even string. I don't know exactly what function they use for the string. String, they can all use min-max. Yeah. For count, you can just get from the metadata. Yes. Yeah. Impala, Kudu currently doesn't provide the statistic, the cardinality. It doesn't provide cardinality. We can still do compute stats for Kudu table so that we can get table level statistic, but it doesn't get per partition level. So we don't know the cardinality per partition. On Impala side. This is because right now Kudu doesn't have this functionality to provide that information. Yeah. You mean manually modify the statistics? There's a command, SQL command. You can do an alter table set to set the statistic.
Are there any underlying table types that does not work with Impala, or any table that Impala can query, you can set the stats to?
Any table, because the table is stored in HMS. No matter what's underlying storage you use, so they do have the statistics saved in HMS, even the Kudu table. Yeah.
For median, also there's the APEX median.
Upshas median, yes, that's for some, yeah, you can use that one. Probably can do the calculation quickly. Yeah. Approximate median. So it's kind of one function to give you estimated the median value. Yeah, so it's probably faster than just iterate every value to calculate the median. Yeah, I'm going to start to explain the difference here. Yeah. Okay. So as I mentioned many times, when we have the profile, the different performance, you should, most of the time, you should start with execution summary. So this is the one that takes shorter time. This one take longer time. And if you look at the average max time here, if you look at the average max time here, you can see at the scan level, each of them like usually just milliseconds, even the longest one. But if you look at the second one, you can see here that the scan take seconds here. And look more detail about the output of this operator. This one, the output is 120 million. But this one is only 460K. So you can, now you have rough idea, oh, the scan is different. Why the scan is different? So let's go back to the plan to see what's the difference here. So this 00 here, this is the operator ID. This will map to the ID in the plan here. So you can see this one here, although they both have predicates here, but the difference here, this one, it says Kudu predicates. This one is just a normal predicates. When you use Kudu as storage, not all the predicates can be pushed down to the Kudu level. So for those kind of operator like large, equal, smaller, those predicates can be pushed down to Kudu level. So we can just do the filter at Kudu and return last result at Impala layer. But for this one, since this one here is not equal cannot be pushed down to Kudu level. So what we do is, Impala do is it will read all the data from the Kudu first and do the filtering at the Impala layer. That's why there's big difference between the scan. If you put all there, then it also cannot be pushed down. I would suggest you just check Kudu's document to see like which predicates can be pushed down, which cannot. Yeah. Parquet support better predicates push down. I don't remember like everyone, but you'd better check document. But for Parquet, we do support a little bit better for predicate. The text format. It's not because the data type. It's because what's the expression here? If it's not equal, or if it's equal, if it's in, or if it's not in, this kind of thing. It's not the data type. No, it's not really with the file format. It's just for different file format, we can do different optimization. If you're doing Parquet, we can only scan this column. But if you're doing a text, even though that you just read one column, you still need to read the whole thing because you cannot easily break them by column. Yeah. Okay. Okay, good. So let's take a look at the second one. So for this one, I'd like to ask you to compare the Parquet remote read with this Parquet second run. By the way, this is actually end of the first part. If you want to take a break, feel free to take a break. And we will start after we finish exercise, and we'll start the second part at 3:30.